concavity and inflection points. All right, let's give a picture of what concavity looks like. So if I have a structure that looks something like this, this would be termed concave down. These are just visuals. If I had a structure that looks like this, that would be called concave up. So as a function increases or decreases from one point to another, you could do it in numerous ways. So let's imagine this is increasing. Two increasing examples here. F of x is increasing, but there are two basic ways it can increase, right, according to the idea of concavity. It could increase from, I'll just try to mark the same points that the curve is going to possess, maybe here and here, something like that. You could increase along the curve from one point to another in a concave down sort of way, or you could go in a concave up sort of way. Right? Either way, you've gotten from this point to this point, but again, there's two basic ways. There's also no concavity whatsoever, you might say, if it was just a line, but barring that particular situation, just in general, a curve moving from one point to another has two basic ways, a concave down sort of way, a concave up sort of way. So too, if the function is decreasing, it's not that different. F of x is decreasing from one point to another. It has two basic ways it can do it, same two basic ways. And if we're up here, we're going to go down to here, similarly here to here. It could do it in a concave down sort of way. You could do it in a concave up sort of way. All right? So we'd like to know, besides what we know already about increasing and decreasing, right? You see there's different types of increasing and decreasing. We want to further characterize how it's increasing or decreasing from one location to another. We'd like to know about its concavity. Right? I'll draw another picture, try to illustrate what's going on here and how it relates to derivatives. All right. Here's f of x. Something like that. All right. So we see, I hope, about concavity here. I would claim that it looks like it's concave down. So I discussed at the very beginning, right? Concave down, this type of visual. It's concave down all along here until maybe somewhere in here. It's hard to tell exactly where this is happening, but it looks like it's changing concavity maybe right about there. Okay, let's call this A for a minute. Looks like it's changing concavity right there. And then after that, it looks like it's concave up. Right? You could argue easily, has a concave up kind of structure there, just like we described up here in this first very small picture. Right? Concave up. It's opening upwards. All right, so what's going on with the derivatives though? If we start drawing tangent lines to the curve, I'll take a few locations here. Something like that. A little off there, but it's not that big a deal here. Something like this. That. Keep going. Now we know there's a zero tangent right here, right? There's a zero slope, and that would be a location of a relative max. It's not the concern at the moment, but we can see that the derivative is going to taper off here and become zero for a brief moment. And we can see the derivative is positive on this side and is negative on this side. So that's what we discussed earlier about finding relative extrema. So like that. I'll try to draw one more without making it too messy. Like this. All right, so there's a picture of what's going on with the slopes of the curve until we reach this location where it looks like it changes concavity. Now I'll draw another picture on this side. I'll draw some more tangent lines. What's going on here? On this side where it appears to be concave up. I'll try to discuss in a moment what is different about these two situations. Again, there's a relative minimum here, not of concern for the ideas presented at the moment, but we do see, as noted before, that the derivative here is positive on this side, but negative on this side, right? We've got positive slopes here, but negative slopes here. So we're going through a relative minimum. And maybe something like that. Try to draw one more, getting a little messy. All right, that'll just have to be good enough.